Hello everyone, welcome to my YouTube channel MechE-FUNdaMENTALs. In this video, I will discuss about the 4-stroke petrol engine. In the series of Fundamental of Mechanical Engineering, the topic is 4-stroke petrol engine, which is also known as spark ignited engine, SI engine. So in this video, I will talk about the heat engine, types of heat engine, types of IC engine, engine terminology, and the working of 4-stroke petrol engine. Now the first, that is about the heat engine. So heat engine is a machine or a device which convert the heat energy into the useful work or the mechanical energy. So the conversion of the heat energy into the work or the mechanical energy, that is by the heat engine. So we convert the heat energy into the mechanical energy, okay? And whatever the remaining heat, that goes to the surrounding, or that is the waste, okay? So it means we are converting the heat energy into the work, because the efficiency of the heat engine is not 100%. So the total heat energy cannot be converted into the work. If that is possible, it means the efficiency of the heat engine is 100%, okay? So practically it is not possible because we have the loss of the energy. So that loss go to the surrounding. So that is the concept of the heat engine. Now the types of heat engine. As we are converting the heat energy or the thermal energy into the mechanical energy. So again, we have the two types of the heat engine. The first one, that is known as the internal combustion engine. In short, it is known as IC engine. The second is the external combustion engine, EC engine, okay? So now with the help of this diagram, I explain what is the meaning of internal combustion engine first. Internal combustion engine, it means there is a combustion. Combustion means there is a combustion of fuel. So when the combustion of the fuel, you see here that red zone or the red region, here the combustion of the fuel takes place. This is the cylinder of that engine. This is the piston, okay? So when the combustion of the fuel that will take place inside the cylinder, that engine is known as the internal combustion engine. Again, I am repeating, when the combustion of the fuel in the heat engine that will take place inside the cylinder, that is known as internal combustion engine. And all the automobile engines are the example of IC engine, okay? Now see the next one, that is the external combustion engine. So it means the combustion is not inside the cylinder, that is external. And the steam engine is the example of that. Now you see here, this is the coal, this is the burning coal, which will give its heat to the water, and water converts into the steam, okay? So the combustion is here, and that steam then goes to that particular cylinder. So here we have the cylinder and the piston, because the power is developed by the piston, okay? So now see, the combustion is not inside the cylinder. This is the cylinder. The combustion is outside the cylinder. So this is the location where the combustion takes place. So this type of the engine is known as the external combustion engine, and the steam engine is the example of that. Okay, so these are the two types of the heat engine, and here our focus is 4-stroke petrol engine. So that is one of the automobile engine. So that I have to discuss in this video. Now, as I already told you about the IC engine, means the combustion is inside the cylinder. So again, we have the different types of the IC engine. So here I take this main classification. The first one, that is based on the type of the fuel used. So it is the petrol engines, diesel engines, or gas engines. This means what type of the fuel you are using. What type of the fuel actually ignite inside the cylinder, the combustion of that particular fuel. If it is petrol, we are using the fuel as a petrol, then that IC engine is known as the petrol engine. If the fuel is the diesel, then those IC engines are known as the diesel engines. And if it is a gas, like you see the CNG, so that is the gas engine, because the fuel is the gas, okay? The second, that is based on the number of strokes. So in this we have the 2-stroke engine and the 4-stroke engine, because from that engine the power is developed. So when we are getting one power cycle or one thermodynamic cycle by the 2-stroke of the piston, okay? So the piston will move inside the cylinder. If it's two-stroke will give you the one power cycle, then it is known as a two-stroke engine. And if you are getting one power cycle or the thermodynamic cycle by the four-stroke of the piston, then it is known as the four-stroke engine. So in the coming slide, I will also explain that difference with the help of the diagram. The third one, that is based on the mechanism of the ignition, how the fuel ignite, how that ignition or combustion is initiated. Okay, so if the spark is actually ignite the fuel, then those engines are known as the spark ignition engines, SI engines. Okay, when the compression actually initiate that ignition and then the combustion of the fuel takes place, then those engines are known as compression ignition engines, then that is CI engine. So SI engines, spark ignited engines, and CI engines means these are compression ignition engines. Now here the engine terminology. So you see this is the some real view of the engine, and this is actually the block diagram. So first we have to see this block diagram. Okay, so first I will tell you the main terms which used in any engine. You see the first one, the first main component, that is the cylinder. You see these outer lines that will give the information of that cylinder. So here you see this is the cylinder. Okay, and the second, that is the piston with piston rings. Okay, so this is the piston which will move to and fro inside the cylinder, so that will move up and down. You see this is the piston which is moving up and down, so that piston translate inside the cylinder. Okay, and the piston rings are also attached. You see these are the piston rings, so that the contact between the piston and the cylinder, that will be minimum, because that is for the less wear and tear. Okay, so when the contact area is small, so definitely wear and tear is also small. That is the objective of these piston rings. Now when the piston will move inside the cylinder, so you see this is TDC and this is the BDC. So TDC means that is the top dead center, and BDC full form, that is the bottom dead center. It means the topmost position of the piston when it will reach here, so that is known as the top dead center. Okay, and when the piston is its bottommost position, it means that is known as the BDC, bottom dead center. It means the extreme up position, that is TDC, the extreme bottom position of the piston, that is BDC. It means the piston will travel in between TDC and BDC. Okay, so it means this complete translation either from TDC to BDC or from BDC to TDC, that is known as the stroke. As I already told you, the classification of the IC engine, two-stroke engine and four-stroke engine. So in that we are using a word stroke. Okay, so this is the stroke. So piston moves from one extreme position to the other extreme position, that is called one stroke. Okay, now you see here, so this is the piston pin or the crank pin. You see here in this diagram, this is the piston pin. So the piston pin member is attached, that is known as the connecting rod. Okay, so this is the connecting rod, and the other end of that connecting rod, that is known as the crank pin. And this crank pin, again we have an additional member which is attached with crank pin, and the next point, that is the crankshaft, so that is known as the crank, and this is the crankshaft. Okay, so this is the cylinder, this is the piston. Piston will move up and down, to and fro inside the cylinder. So we have the two positions of the piston, TDC, BDC. This is the piston pin, and through that piston pin, connecting rod is attached, and the connecting rod's other end is known as the crank pin. From a crank is attached, and finally that is attached with the crankshaft. Okay, now you see the piston will move up and down, and this crank will rotate like this. If you see here the diagram, this crank is rotating and the piston is moving to and fro, up and down. That is the translation of the piston. Okay, so now here this is the inlet manifold from where the fuel will enter in that particular cylinder. So this is known as the inlet valve, IV, that is written in short, IV, that is the inlet valve through which the fuel will enter in the cylinder. And this is the exhaust manifold, and this is the exhaust valve. And this exhaust valve opens when the burnout gases will be escaped out to the surrounding. Okay, so through inlet valve, the fresh charge will enter in the cylinder, and when we have the combustion of that particular fuel, and the burnout gases will move out through the exhaust valve. Okay, so these are the basic terms. And if that is the SI engine, the spark ignited engine, so here you have seen the spark plug also there. Okay, so these are the common engine terminology which actually we have to know to understand the working of any engine, it is petrol or diesel. Okay. Now here I am explaining the 4-stroke petrol engine, and this petrol engine is also the SI engines. Why? Because all the petrol engine, the ignition is done by the spark. It means if any engine we have the spark plug, you see here this is the spark plug, it means that is the petrol engine, because all the petrol engines, the initiation of the ignition, that is done by the spark. So if we say the petrol engine, and it is also called as a SI engines or the spark ignited engines. Now it is 4-stroke. Okay, petrol engine means we are using petrol as a fuel, and that ignition is done by the spark, so that is the SI engines also. And why it is a 4-stroke? Because one power cycle, it is completed by 4-stroke of the piston. Okay, one power cycle is completed by the 4-stroke of the piston, then it is called as 4-stroke SI or petrol engine. Now here I mentioned these 4 strokes which will complete the one power cycle. The first one, that is the intake or the suction stroke. The second is the compression stroke. The third is the expansion or the power stroke. So this is the stroke where you are getting the power. So that is the reason why the expansion stroke is also known as the power stroke. And the last, that is the exhaust stroke. So it means we have the 4-stroke of the piston and we complete one power cycle, and these are the main 4 strokes which will take place in that particular power cycle. Okay, because the ignition of fuel is done by the spark, so that is also known as the SI engine. And here the petrol is the main fuel, which is atomized and mixed with air before entering in the cylinder, because through that particular inlet valve, the fresh charge will enter. So when that is a petrol engine or the SI engine, so the petrol is mixed with the air, and that is in atomized form. Okay, so that mixing is done through the carburetor. So that process is in the carburetor. Nowadays the carburetor is obsolete. Now we have the MPFI system, multi-point fuel injection system, but that mixing is there also. So the air with petrol in atomized form will enter in the cylinder, and we have a scientifically perfect mixture of that air fuel ratio, and that is 14.7:1. So this is the chemically correct ratio, because if we have the chemically correct ratio of this fresh charge, then we have the normal combustion. If that is other than this particular ratio, so definitely it will affect the combustion, and that is abnormal combustion, and that will decrease the performance of the engine. Okay, so we have a chemically correct ratio of air and fuel, that is 14.7:1. Now the thermodynamic cycle or the power cycle of the petrol engine or the SI engine, that is the Otto cycle. So Otto cycle is an ideal thermodynamic cycle which forms the basis of the working principle of petrol engine. Okay, so always you understand that whenever we have in the thermodynamic processes, even in any cyclic process, and definitely there is any thermodynamic cycle. So for the petrol engine or the SI engine, that thermodynamic cycle is known as the Otto cycle, and you see the property diagram of that Otto cycle. This is the pressure volume diagram, PV diagram. Okay, now again I will show you all the stroke or the processes in this 4-stroke petrol engine in this Otto cycle. Okay, you see first that will start from 0. So 0 means you see this particular position. If I mark this position here, so it means this is the TDC, the top dead center of the piston, that is the topmost up position of the piston. So this is the topmost position of the piston, that is the TDC, and here this is the bottom position of the piston, the extreme bottom position of the piston, that is known as the BDC, because the piston will move from TDC to BDC. So you see TDC, then BDC, then TDC, then BDC. It means the piston will move between these two extreme positions only. So when we start with 0, so 0 to 1. So 0 to 1, the piston is moving from TDC to BDC, though that is TDC to BDC. Then we have the intake stroke. It means the fresh charge will enter in the cylinder. Then 1 to 2, the piston will move from BDC to TDC. Then we have the compression. Okay, and just at the end of the compression, we have the combustion of the fuel, and that the heat is added on that. So 2 to 3 process, it means that is the process of the combustion where the heat is added, and you see the pressure increases due to that combustion. And then the piston will move from TDC to BDC, because now you are getting the power, because due to that thermal energy or the combustion of fuel, a huge thrust is exerted on that particular piston, and the piston will move from TDC to BDC, and that is the power stroke. This is the actual stroke. Okay, when that stroke will complete, the exhaust valve opens, and then we have the heat rejection, due to which the pressure will drop, and finally from 1 to 0 we have the exhaust stroke. Okay, so again I am repeating, 0 to 1 the piston moves from TDC to BDC, the fresh charge will enter. Then from 1 to 2 the compression takes place, the piston is moving from BDC to TDC, and then at the end of the compression the ignition takes place through the spark, the heat is added, and by addition of the heat the huge force will exert on the piston, and the piston will move from TDC to BDC, that is the expansion. And just at the end of the expansion stroke, the exhaust valve opens, the heat rejected, and the pressure will drop up to the atmospheric pressure, and then finally the piston will move from BDC to TDC, and that is the exhaust stroke. So this is the Otto cycle, which will tell us about the working of 4-stroke petrol engine or the SI engine. So now one by one I again explain these strokes in the coming slides. You see, so here now I will explain again to make the concept more clear. So the one power cycle or working cycle is completed by the 4 strokes of the piston: suction, compression, expansion or the power stroke, and at last I have the exhaust stroke. Okay. Now see, suction stroke. Suction means that is the suction of the fuel or the suction of the fresh charge inside the cylinder. So already I told you, in this particular stroke the inlet valve remains open. You see, this is the inlet valve and this is the exhaust valve. So in the suction stroke, inlet valve open, you see we have the passage of fuel, the fresh charge will enter from here, but exhaust valve closed. Okay, and in this particular suction stroke the piston moves from TDC, you see the arrow, this is the direction of the piston motion. So this is the TDC, this is the BDC. It means the piston is moving from TDC to BDC. So during the suction stroke, inlet valve opens, exhaust valve closed, and the piston is moving from TDC to BDC. And when this piston is moving from TDC to BDC, so a partial vacuum will create here. Okay, a partial vacuum is created inside the cylinder, and the petrol and air mixture will enter into the cylinder. So we have the mixing of the air and petrol, that is in the carburetor, and through the carburetor that fresh charge will enter in the cylinder due to generation of the vacuum inside the cylinder. Okay, now the piston is moving downward, the fresh charge enters in the cylinder, and at the end of this stroke, it means now the piston is at the BDC. What happens? The cylinder will fill with completely with the petrol air mixture, and that is also known as the charge, that is the fresh charge we can say. And then at the end of that stroke, now that inlet valve also closed, and this is the suction stroke. Now the second is the compression stroke. Now when we start the compression stroke, now you see the arrow, so it means now the piston is moving from BDC to TDC. So that is the motion of the piston from BDC to TDC, and inlet valve as well as the exhaust valve remains closed. You see both the valves are closed during that compression stroke, and already a fresh charge enters in the cylinder, that is filled with the fresh charge, that is the petrol and the air mixture, and now the piston is moving upward. What happened? The petrol and air mixture contained in the cylinder will be compressed, so pressure as well as the temperature of the mixture increases. Okay, now at the end of the stroke, now let us suppose now the piston is at the TDC. So this is the position. Now the fuel will be here, that compressed fuel will be in this region. Okay, at the end of the stroke, air fuel mixture is ignited by the spark. So when we have the just end of that particular stroke of the compression stroke, and that fuel is trapped in that particular small volume, at that instant the spark initiated. Okay, so by the initiation of the spark, the combustion takes place, and which release the hot gases, which will increase the pressure inside the cylinder. Okay, so the combustion is just at the end of the compression stroke. Now the third one, that is the expansion of the power stroke. You see that particular red portion, it means now that is the combustion of the fuel, the hot gases are generated. So when we talk about this power stroke, so what is the motion of the piston? That is from TDC to BDC. So that is the expansion, because that burnout gases, hot gases, it means now that will give a huge thrust on that piston, and the piston will move downward. So that is the reason why this is known as the power stroke, because the power is developed during that stroke. Okay. So the high pressure and high temperature burned gases force the piston to perform this stroke, and this is known as the power stroke. Okay. And again here the inlet valve as well as the exhaust valve is closed, and we are getting the power. Now the last, that is the exhaust stroke. Now the piston is at the BDC, and these are the burnout gases, because they perform their work. They give huge thrust to the piston, the power is already developed. Now these are the burnout gases, and when at that exhaust stroke, the piston will move from BDC to TDC, and this exhaust valve opens actually when that will start that particular motion, and due to that our pressure will drop. Okay, and whatever the burnout gases that is inside of the cylinder, that will escape out from the exhaust valve. So whatever the burnout gases we have during that exhaust stroke, where the piston is moving from BDC to TDC, inlet valve is still closed, but the exhaust valve opens. So all the burnout gases will escape out. Okay. So at the end of the exhaust stroke, the exhaust valve is closed and the inlet valves will open. It means now when that stroke is completed, the exhaust stroke, then again exhaust valve closed and the inlet valve opens, because now we have the fresh cycle. So again we have the suction, compression, then we have the expansion and exhaust. So in this way the cycle operates. Now here in this slide you see all the processes in a single diagram. The first one, that is the intake or the suction. The piston is moving from TDC to PDC. Through this inlet valve the fresh charge enters, that is the air fuel ratio. The exhaust valve is closed and the piston is moving downward, so that is the intake. Okay. Now in the compression, the piston is moving from BDC to TDC, both the valves are closed, and just at end of the compression stroke the combustion takes place, and when the combustion takes place through that spark, then we have the expansion stroke. Now the piston is moving downward, because a huge force will appear in that particular piston and we are getting the power. So this is the power stroke or the expansion stroke. Okay. Now the last one, that is the exhaust stroke. The piston is moving from BDC to TDC. Inlet valve is closed, but the exhaust valve opens, due to which all the burnout gases will escape out to the surrounding. So suction, compression. At the end of the compression we have the combustion, and then we are getting the power during the expansion of the power stroke, and then at last we have the exhaust, means all the burnout gases escaped away. Okay. So this is again the cycle. So 0 to 1, that is the suction or intake. 1 to 2, that is the compression. 2 to 3, this is just at end of the compression where the spark takes place and we have the combustion. So that is a very intermittent phenomena. Okay. Then 3 to 4, this is the power of the expansion stroke. When the piston is just at the BDC, the exhaust valve opens, so we have a little drop of the pressure to the atmospheric pressure, and when the piston will move from BDC to TDC, then we have the exhaust stroke. So main we have the 4 stroke: intake or the suction, compression, power of the expansion or the exhaust stroke. And these heat addition or the heat rejection, these are very intermittent phenomena. This combustion, that is just at the end of the compression, and this heat rejection, that is just at the end of the expansion stroke. So these processes are also added in this Otto cycle to do the analysis of that particular cycle completely. Okay. So hope you understand the working of 4-stroke petrol engine or the SI engine with the help of this video. Thank you.